Actually, this week is week 23, right? It's very quick. We only have, including this week, we only 10 weeks left. So including the last week will be final exam. So actually we only have 9 weeks left. So we need to be quick. All right, so let's continue our factor part. Just factor trinomials. So we move to some specific situation. Some of the trinomial, actually we earlier learning, right? We already learned square of the binomials and go this way. Something like say x squared plus x plus b squared. This one equals to x squared plus 2bx plus b squared. You guys remember this one, right? Ready? If you're not, go back to check it, the earlier what we learned. Second one is x plus b, x minus b for the specific product. This one equals what? X squared minus b squared, right? And we also learn the third one, a plus b. If they times a squared minus ab plus b squared, this one equals what? A cubic plus b cubic, right? We learn this one, right? And the second, this one is we change b to negative b. Here b change negative b. So this one equals what? A cubic minus b cubic, right? So this is special product. We already learned. So when we met these kinds of trinomial, when we factor them, we can factor back, right? If you, this is can be factored into like this, backward, right? So let's see some examples. So actually just like with special product earlier, we learned the special product. Right now we do the reverse progress. Let's see some examples. Like this one. You can see x squared plus 4x plus 4. This one actually just like last week we were learning. We can factor 4, right, into 2 times 2. So this one can quickly get factored into 2 times 2, 2 and 2. The product of the 2 and 2 is 4, right? The sum of this 2 and 2 will be 4 as well. So can match up, right? Like this one, 6x plus 9. So this one can be what? 9 can be factored into 3 times 3, right? The sum of them would be 6. So this one would be actually x plus 3 times x plus 3. The only situation right now is we rewrite this one is x plus 2 squared. Like this one, we right now rewrite into what? Rewrite it into x plus 3 squared, right? So if you guys do this one, you can definitely go this quickly, right? Right. So we have some special situation. Right now, this one factor is 1. Yes, you guys easy to understand, got this progress, right? Something like this one. This is one. How you factor this situation. I keep this in here first. I don't like factor this one. Let's keep this one a little bit later. All right. Keep these 2 examples a little bit later. We will come back to do these 2 examples a little bit later. All right. Let's go next. So we know the perfect square situation. When you met x squared plus 2b x plus b squared, what it means when you see the numbers, when the trinomials, you can see the last number c here is some number square. Double check this number, the coefficient of in front of the x is exactly 2 times of the numbers? If yes, they can be made the perfect square. They can be factored into this one quickly. Just like what we earlier learning. If the 16 is 4, right? So double check the B is 8 or negative 8 or not. Something like say x squared minus. So this one, you can see this one is 4 square, right? This is 4 square and also negative 4 square. So this one can be quickly, you can quickly transfer into like a minus 4 square. Something like here. You can see this is 49. When everyone can quickly remember 49 is 7 square. 7 square. Negative 7 square as well. Equal 49. So you can double check this number. Coefficient in front of here is positive 14 or negative 14. They both can be transformed into x plus 7 or x minus 7 square. If they are positive, here is positive, right? If a negative, here is negative, right? So this is the part about the perfect square, how you judge them quickly, if they are perfect square or not. All right, second one, we go to second special product, a plus b times a minus b. We know this one can get a squared minus b squared, right? So we also need to check this situation. When there's only two binomials, each of the term can be divided into something square. So they can be easily be factored as well, right? Something like this, these examples. 4x squared minus 1. This square, 2x squared can be divided into like this. Right? So like you can see this situation. Is A is 2x, B is 1. So it means they can change into like this. 2x plus 1, 2x minus 1. If not, you can do backward. Earlier, when you do this progress, you can do the product of the two terms, sum of two terms, difference of two terms, their product into like this, right? So you can, so our progress right now, do factor progress actually exactly the reverse progress of the product and the product progress. Same to this, see these examples. You can see 25a squared, 9b squared. Actually, this rewrite is 5a squared minus 3b squared. All right, so this one can be divided into a, can be factored into what, like this, right? So you do backward, you can get this step and got this step, right? Same. See these examples. Number C. Example C. So here you can change into y squared minus 2/3 squared, right? So this one can be changed into y plus 2/3 y minus 2/3. Right? So see this kinds of situation, it make it much easier. All right. So let's see number 5 here. Number 5, more example. Make it a little bit more changed format. First, we see this expression, 4x cubed minus 49x. Actually, this one, they already have common factor, right? We take x out first. So what are the rest? Rest is 4x squared minus 49. So this one we can rewrite 2x squared, right? This one is 7 squared. Right? So inside here is 2x squared minus 7 squared. So we can write this part into 2x 7, 2x 7. One is plus, one is minus, right? So we can get a reverse progress, get the latter part, get it back here. All right, let's see number 6. Same situation. So 161 and 2. Right now we can take 2 out first. So rest inside is 81x power 4, right? Minus 1. Right now it's go higher level. Okay, so 81, we can rewrite it into what? We'll rewrite it into what? Let me write it different way. Like 9x square minus 1 square, right? So one of them is 9x squared, one of them is 1, right? So what's the rest? So the rest we copied it here first. So this part is became what? 9x squared plus 1. 9x squared minus 1. Did you see that? So here is first one squared, right? We added the square. Second one and squared here. Did we done this one? Did we fact this one completely or not? 2 definitely cannot be factored. 9x squared plus 1. This one we cannot be continue factor, right? This part. What are you looking here? This part. Actually, this part, you can rewrite this part into what? 3x squared minus 1 squared, right? This part can be rewritten like this. So it means what? It means this part can be continuously factored. They didn't factor completely, right? This one can continue be factored. So let's copy the first part first. So what about this part? The rest of this part. This part actually will rewrite this one, right? So it means this part can be rewritten 3x 1, 3x 1. 1 is plus, 1 is minus, right? So this one can be changed for here. Match to here. So right now we completely factor this one. Actually, this one you can, how many steps you do it here? Multi-steps, right? Multi-steps, because of this higher degree, and you can factor into step, take the common factor out. Second one, you can rewrite this part, and this part can be factored into 2 of them. And since we factor 2 of them, this one can be further factored. So we can go to this step, right? All right, take your homework out, note out. Can you guys factor this one? Let me circle here. Circle, factor this one. Y power 4 minus 16. Take your notebook out, write the answer right here on the screen. Let me. All right, can you guys write this one? So actually this one, we can do the same right here, okay? So y power 4 minus 16. We can rewrite it here, right? Y power square. 16 is 4 square, all right? Right? All right, so this step, so can be factored into what? Y square 4. Y square 4, right? 1 is plus, 1 is minus, right? Is it correct, everyone? All right, so this one, second one here, this 4 we change into 2 square. So it means this one can be further factored. Let's copy down this part first. So this one can be further factored. Can be further factored into what? Y plus 2, y minus 2, right? This plus and this is minus. So you can get this step, right? So this is completely factor progress. Okay, so we're done for this part. So whenever when you factor this one, you can use the special product progress. Actually, we do this reverse. Right now we do backward. Factor into 2. Let's move on more. Let's see more examples. For this number B, these B examples, x squared plus 4, this one cannot be further factored, all right? So here is plus, is not minus here. So this one cannot be factored, all right? All right, let's see next examples. I save some screen and go to next. Just like we say earlier, when we do special product, did you guys see this? A plus B times A squared plus minus AB plus B squared. This one can be equal here. Right now we do backward. Do backward, all right? Backward. The same here, do backward. So see the examples. Let's see some example like this one. See 35 here. This example actually, you can see 27 is 3 power 3, right? Ax cubic. This is 2x power 3. So we consider here A, this equal A, right? B equal 3. You can see that. You can see that. You can use this formula to factor the progress. So it means here can be factored into 2x plus 3, right? This one A equal 2x, B equal B. So first we can factor this part. And second part is we just replace A with the 2x, B with the 3, right? So here is 2x squared. So I need to change this one into a bracket. Okay, minus 2a and b, right, plus b squared, right? So actually this is a plus b. This is a squared minus ab plus b squared. Let's organize them. So here got a 4x squared minus 6x plus 9. Right? We organize here. Right? So make it more easy, right? All right, see 36 examples. So here 2x cubic, ax. Actually 2x is the common factor. We'll take 2x out first. All right, so you can see 2x x squared plus 4. This one cannot be further factor. So this is end. This one is finish the factor progress, right? Finish progress of this one. See 37. See 37. This specific kinds of example. 54 minus 2x cubic y cubic. All right. So see the factor part. 2 is their common factor. Right, we take 2 out first. This is 27. This is what? X cubic, y cubic. If you're more happy with this one, you can also write like this. Take a negative 2 out first. Right, so we can rewrite it like this. Both works. So currently, the most important thing is we can see here, this one, they can rewrite it into xy cubic. And this one, 27 is 3 cubic, right? So we can factor this part into A cubic minus B cubic can be factored into like this. A minus B and time A squared plus AB plus B squared. So A is XY, B is 3, right? A is XY, B 3. A is XY, B is 3. What about the rest? A squared plus AB, so 3XY plus B squared, 9. Right, so it means this one can be factored into here, this progress. Okay, so actually this one just use this formula. You try to identify A, try to identify B, and then use the formula to factor these kinds of cubic progress. All right, actually this question, all right, let me go back here, go back front side first. Let you guys print screen this one, because of this one sometimes take a little bit longer to understanding. I know there's a little bit challenging part right now. We move some challenge part. All right, so I clean the screen. Next slide here. This slide, let's have several new signal here. You guys may be challenging, maybe not challenging. This is actually this one I saw from one. Did you guys call AMC 8 competition? American Math Competition for 8th graders. AMC. Did you guys who in the AMC 8? Anyone in the AMC 8 ever go AMC 8 math competition? Anyone in our class go to math competition before? Hello? I don't heard anyone say yes. Anyone go to the AMC 8 math competition before? No. Okay, it's fine. So actually this one, interesting. Here is a question from AMC 8. I thought it's so close to our what are we learning. So I just take it here for practice. So actually this one is a function. This is a function equal this x cubic plus x cubic reverse. So when f equal, it means when this part equal 4, when the inside part equal 4, what the result would be? This exactly use what we're learning right now, actually. Okay, let's see here. Let's see here. So we just consider something like this. Did you guys learn this? We're just learning this one, right? We're just learning this one. So this one we can consider what? This is a cubic plus b cubic. So this one can be factored into what? A plus b, right? A squared minus ab plus b squared. So it means this one can be factored into what? One of a is what? A is x, right? B is 1 over x. All right. Okay. So it means this one can be factored into what? X plus x first. So second part, what about second part? A equal x, b equal 1 over x, right? So a squared minus what? Here is x over 1, right? Everyone understand this progress? We factor this one. A equal x, b is 1 over x. Okay, so actually this one is x squared. Here equal what? Minus 1, right? Minus 1 plus x. Did you see interesting part here? All right, so we know this part. What do we need to do? We get here. We change this a little bit. We here plus became +2. We change this one. Actually, most tricky part is right here. -3 here, right? Here is 2, right? We +2. We need a -2. So -1, one more. So we became -3. You can see here is +2. Here is -1. So combined together, still -1, right? All right. So what do you see this part? This part actually can change into like this square. Did you guys see this x plus? Did you see this one? This part? This part can be changed exactly like this, right? X squared, second p squared, and 2 times of these 2 terms. Product of these 2 terms. All right, so go back, check this one. All right, so we suppose this is a t. Suppose this is a whole number, a t, a huge t. We say this one is equal to t. So ft equals what? T times t squared minus 3. Why? We know this one is a whole number. So right now it states this is equal 4. Suppose t is equal 4. So 4 times 4 squared minus 3. You guys can do this. 4 times 16 minus 3, 13 equal 52. The answer here is 52. We can use our knowledge right now to find some competition. Actually, the math competition is, they just do a little bit additional step to our what we're learning. So this is from AMC, American Math Competition for 8th grader or a little bit higher people. So you guys, most of you guys in the 7th grade, maybe in near future, we can use these kinds of knowledge as well. So this is example, very good example for you guys. Hopefully you guys can learn from this one. All right, this is additional one from the American Math Competition. I capture the topic and just put it right here. Hopefully it can help for you guys. All right, so let's move on. Next topic of today. So previously, before right now, we most time is factor x squared plus bx plus c. The factor in front of this is 1. All right, so we can do that one easily right now because we can factor c and find the factors. Some of the factors can exactly match b, so we can do that work like this way. So right now we have met more complicated situation is the a actually is not equal 1. Like this ax squared plus bx plus c. This a is not equal 1 or even higher, bigger numbers than 1. How can we factor them? How can we factor these kinds of trinomials? How can we factor these trinomials? So let's see these examples. See this example. How we factor them? We cannot only factor, this is a little bit different, right? This 3, and here is b is 11, and c is 6. If you match up this description, ax squared plus bx plus c, the coefficient of here is 3, 11 for b, and c is 6. So how we factor this one? We cannot use the earlier methods. We cannot use the earlier methods. Factors this c. We factor this c. It's because of the factor of in front of this one here is only 1. All right. So what do we need to do? Listen carefully. What do we need to do here? All right. So my first step is find out a, b, c. All right. Find out a, b, c. A is the coefficient of degrees of 2. B is the coefficient of degree 1. C is constant number. So first step, we find A times C, time product of them. All right. So here product of them is what? 36. 3 times 6. So here equal 18. First step is 18. All right. Find 18. Find A times C. Second, do the same as the before. Factor this number. Factor 18. Factor 18 into what? 18 can be factored into what? Right now, can be into 1 times 18. -8 by -18. Like earlier, we factor C progress. Factor all into pairs, possibly half. Let me factor into 2 times 9, -2 times -9, 3 times 6, -3 times -6. That's all, right? That's all for current, for 18. And then the third step, find the sum of them. Sum of here is 19. A little bit familiar, right? You guys, earlier is factor C, find pairs of the factors and find sum of them and try to match to the B. This is progress exactly like the earlier one right now. Find sum of them. So here is -19. Here is +11, -11, -3. I'm sorry, the 3 times, oh, here is 9. And here is -9. And then find this sum of them, sum of the factors. Pairs of factors, sum of pairs of factors. See, we find each of the pairs, right? And number 4, find which one match to B. Find sum of this one can match to B. The B here is 11. Come here is 11, right? So which one match? Actually, this one match to 11. Right? So it means they can break it down in this 11x can be broken down 2 times 9. All right? So actually this one I need to write down here. The 5th step. So the 5th step is do like this. 3x squared. So right now it's 2 times 9, right? So it means this 11 breaking down 2x plus 9x plus 6. So let's this 2 and 9 come from. Okay. What next is group factor. Group factor. We group this and group this. All right. So x, 3x plus 2, right? This is 2. Common factor is x. What about this one? It's 3. 3x plus 2. All right. 3x plus 2 is the common group factor. Take it out. So the rest is here. So you can see this one actually factor into like this. Let's check it. 3x squared, right? This 3x squared. Here is 9x. Here is 2x. Total is 11x. And last one is 2 times 3. You got 6. So it means this one, you got to finally factor is here. So you can see what's the difference from this step to previous. When the factor when the degree of 2, the coefficient is 1 situation, we put A times C first. We add additional step here, right? A times C before they factor C. Additional step, A times C first, and then do the progress, simulate like here. All right, let me print screen this one first. You guys can save screen first as well. Let's see second example. Let me use different colors, okay? The second example. So what do we need to do? First, A times C, right? Find ABC. A is 8, B is -12, C is 5. So first step is A times C equal what? 8 times 5. Right now is 40, right? Then now we continue factoring. Factor this one, factor A times C. We want to find out the sum of them exactly match -22. So work this in your mind. 40 can be factored into -20 times -2, right? So the sum of this one match to -22. All right. So it means this part can equals to what? Ax squared minus 20x minus 2x, right? That's 20 and -2 is come from here, right? So the rest is 5. So we do the group factor. First group is 4x, right? 4x is the common factor. So became 2x minus 5, right? Second, take a -1 out. The rest is -2x minus 5. So -2x minus 5 is their group factor. Right now, we finished. It's easy, right? Much easy than earlier. All right, take your notebook, finish this one. If you correct, you can leave in. We're done for this class. Take your notebook out, do this one. On the screen, I circle here. When you answer, write your answer on the screen and can, if you correct, you can leave in. I can give you a hint. A is 2, C is -4, -8, -7. So first step is A times C equal what? 2 times -7 actually is -14. -14. Factor them, so make sure sum of them exactly match 13. Would be what? 14 times -11. All right, so it means this one equals what? 2x squared plus 14x. I cannot write too much, right? You can guys do the rest. You guys do the rest. All right. Write your answer on the screen, okay? I clear the rest. Two x plus 1. Iris, long Iris. Oh, 2x plus 1 minus 1 or plus 1. I talk too quick. Amy, you correct. Okay, I erase your part. You correct. You can leave in. Iris, you correct. You can leave in. Sorry, you can leave in. Jeffrey, you can leave in too.
I can't write on the screen.
Oh, you write it on the chat about?
Yeah.
Okay. Yeah, Jalen, correct. Elena, you're correct. Let me see. Angie, you're correct. Okay. That's 3 more. I mean, you're correct, all right? Right? I thought you first one.
I wrote mine in the chat.
Okay. Let me check. Okay, good. Excellent. Everyone do good job. Max, you write on the screen, right? Is it you writing here? 2x plus. Okay, you done. You maxed that work. Oh no. Okay. All right. So write on the screen. Your mic doesn't work. Okay, you can write on the screen. Right, my Max. All right, everyone. Max, you can leave in as well. All right. Have a wonderful day.